Good evening, sir. Good evening, everyone. Our topic is about multiprocessor and multi-core computers. Here we are all excited to discuss a fundamental topic in the world of computing, microprocessor and microcore computer system. I am Jagruti Jiralikar and my group members are Saishwari and Shital. So let's start our presentation that as technology continues to evolve, understanding this component is essential for grasping how modern devices operate from smartphones to supercomputers. Today we will explore what microprocessors are, their architecture, significance of microcore systems in enhancing computational efficiency. Let's dive into. We will discuss the all topics mentioned here in a in our canvas. So first of all, the definition for multiprocessor and multi-core computers are as a microprocessor is the central processing unit of a computer system, which encapsulates in a single integrated circuit. It performs the basic arithmetic logic control and input-output operations specified by the instructions of a computer program. Now let's see the multi-core computer systems that are sophisticated evaluation of traditional computing architectures. They leverage microprocessors at their core but emphasizes modularity and efficiency. There are some more points about the difference between about multiprocessor and multi-core computers. There are some types of multiprocessor. There are various types of multiprocessor, which includes general purpose processor, which is used in PCs and servers, embedded processors that's found in appliances, automotive systems, and IoT devices, digital signal processors, DSP specified for processing audio and video and other signals. Now it's over to you. The next point will be explained by Saishwari. Thank you.
Hello everyone, my name is Saishwari Korde. My point is multiprocessor and multi-core computers architecture. So, in architecture of multiprocessor, there are uh, each processor can operate independently, often with its own cache and sometimes its own memory. They are connected through a system bus or interconnect. And in multi-core computers, all cores share the same cache hierarchy and memory, which allow for efficient communication and reduced latency between cores. In multiprocessor, the architecture is very complex and is structure composed of multiple independent processors and each with its own memory. And there are two types of multiprocessors, symmetric and asymmetric. It typically uses a shared memory or distributed memory architecture. The scalability is easier to scale by adding more processors, or each can be completed system on its own. And in multi-core system, its structure consists of multiple cores within a single CPU chip. Its integration cores are the cores share the same physical chip and often shares cache and other resources. In memory, generally memory utilization shared memory model accessing a common pool of RAM. Its latency is very low in communication between cores due to proximity on the same chip. Next point is a communication method. In multiprocessor system, each processor is an separate has separate physical unit. Communication occurs over a shared bus or an interconnected network like cross bus or a mesh topologies. And in multi-core computers, multi-cores are integrated into a single CPU chip. They share a common cache and memory architecture, allowing for very fast communication. Next part will be explained by the Sheetal.
So, good evening, sir. My name is Sheetal Udhonirvar, and here I am explaining the topic of data sharing, cost, and money from the difference between multiprocessor and multi-core computers. So, what is the data sharing in multiprocessor? So, the data sharing in a multiprocessor systems refers to the methods and processes by which multiple CPU, central processing unit, communicate and access shared data within a common memory space. Data sharing between processes often requires more complex mechanisms such as messages passing or shared memory access, which can lead to synchronization issues and potential better links. The data sharing in multiprocessor systems that involves the CPU, as I said, accessing and modifying shared data in a common memory environment. While this setup allows for parallel processing, it introduces challenges related to consistency, synchronization, and potential performance better link. Effective data sharing strategies, it includes cache, coherence, protocols, and synchronization mechanisms that are essential for ensuring smooth and efficient operations. So, what is the data sharing in multi-core computers? In a multi-core computers, the data sharing is multi-core computers refers to how multiple processing cores within a single CPU that communicate and access shared data. In data sharing in multiprocessor computers is typically more efficient due to the use of shared caches, allowing cores to access frequently used data within a significant delay. So the data sharing in multi-core computers, as I said, that involve multiple cores accessing and modifying shared data in a common memory environment. This design enables insufficient communication and parallel processing, but it requires careful management of data, consistency and synchronization, effective cache coherence, protocols and synchronization mechanisms that are essential for ensuring that cores operate smoothly and efficiently, maximizing the performance of multi-core systems. So the next point is from the difference that is core and cost and money. So what is the cost and money in multiprocessor system? So the cost and money in multiprocessor system, the cost of multiprocessor system, it involves various factors that are influence both the essential investment and ongoing expenses. Multiprocessor systems can be more expensive as compared to the multi-core computers, and consume more power again as compared to the multi-core computers. It consume more power due to the multiple physical processes. So the cost of multiprocessor systems encompasses a wide range of factors, including hardware, memory, interconnect, software, maintenance, and operational expenses, while these systems offer enhanced performance and scalability. The financial implications requires careful consideration. Organizations that are must conduct through cost benefit analysis to determine whether the investment aligns with their computing needs and the strategic goals. So the cost and money in the multi-core computers. So in the multi-core computers, the cost consideration for multi-core computers, it involves various aspects that impact both initial investment as well as an ongoing operational expenses. In multi-core system generally offer better power, efficiency, and lower cost as compared to multiprocessors. So the cost associated with the multi-core computers encompasses hardware, memory, cooling, power consumption, software maintenance, and potential upgrade. While multi-core system can be more cost-effective than multi-processor system. A careful consideration of these costs is essentially business and users should evaluate the performance benefits against the financial implications to make informed purchasing decisions. So, thank you.
Hello. So the conclusion of our topic, our presentation is that in conclusion, understanding microprocessors and micro-core computer system is vital in today's technology to drive the world. This, their roles in enhancing performance, efficiency, and adaptability are fundamental to evaluating a computers. Let's explore explore these concepts further as we discuss here about the architecture, definition, communication methods, data structures, cost and memory of both multiprocessors and multi-core computers. So this was the difference between the multiprocessor and multi-core computers as we have all explained above. So thank you so much.